Hello. Are we live? Looks like I'm live. Great. Welcome back to my font project. We're working on parsing and rendering fonts. There was a lot of parsing, then we did a little bit of rendering. Now I'm afraid we're back to a little bit more parsing today, not as much rendering. Just to give you a quick demo of where we are. So I can run my program that generates a ppm image, which I can view in GIMP. There we go, fighting with my window manager. And this is it, so we can typeset a word with horrible kerning and outlines only. We're not filling in letters yet. We'll get to that later. So we can do one word. We can do another word on another line. So the first word is pogue. That's pretty pogue. And then we have like the spacing between the letters, which is not a great way to do it. But then we can do a second word on a second line by setting the Y position. This draw glyph function now takes an X position, and that's in my kerning array, and a Y position. So the first line is at line 1, the second line is at line 2, and the Y positions increase as you go downwards. So line 2 is below line 1. I guess you could make very good arguments to have the opposite Y-axis convention. But this is the one that I use because it's good for images too. Like the first row of the image is at the top, so that works the same way. And we can add a second line like this. So I rerun my typesetter, and then I reload my image, and we have a second word on the second line now. We can do different foreground and background colors for each word. Yeah, so that's where we're at right now. The thing that I'd like to address today is that I'm hard coding glyph indices to be typeset. So I'm not like spelling out the letters P, O, G and saying typeset the letter P and the letter O and the letter G. I'm saying draw glyph 51, draw glyph 82, and draw glyph 74. So these are glyph indices in the font file. And what I want to work on today, I don't know if I'll be able to finish it because I sort of have no idea what I'm getting into. Everything that you see me do, I'm learning it basically right now. So what I want to do is parse the cmap data from the TTF file, and that cmap tells you which glyphs are at which index. So then instead of hard coding like the number 51 here, I could say just draw the letter P, and I can pass like the string P or a character P as an argument to my glyph drawer. And that will be a lot more convenient because it's really a pain when I want to do a different word because I have to look up the indices and make sure that I'm getting all the indices correct. It would be a lot easier if I could just put in a string and say typeset this string. So I started to parse the cmap table at the end of the last stream. So go back and watch like the last 20 minutes of that video if you want to see the header of the cmap table. If I look for cmap, yeah, so we have like the cmap version, the number of cmap subtables, because the way that TTF files work is they're basically a collection of what they call tables, and cmap is one table. But then the cmap table itself is a collection of subtables. So we have the number of subtables there. And then we have things like a platform ID and a platform-specific ID. I don't really know what those are used for. Maybe I don't even need to save them. And then we have the cmap sub-offset. I forget what the Apple documentation calls this. There's probably something less generic there. Okay, they just call it offset. I'm calling it cmap sub-offset because I already have a lot of different things named offset. So it's the offset of the mapping table, and that's like the sub-mapping table within the larger cmap table. So I'm calling that, let me get my windows a little bit more organized. Okay, now I can minimize that with one keystroke. So we have that sub offset, and I think that's about as far as we got with the cmap table. Next I have to jump to that sub offset and start reading the data that's within that cmap subtable. So there are various formats. The font file that I'm using, the computer modern file from LaTeX, that happens to be format 4. I don't know how universal this is. I also looked at Calibri. I should spot check a few other font files, but Calibri was also format 4. So format 4 is the one that I'll be focusing on for now. Well, okay, yeah, so the first thing I have to do is parse the format, and if that's not 4, I'm not going to parse it right now because it seems like this is going to be a decent amount of work to not only parse the data from the cmap subtable, but then use all of these parallel arrays to map a glyph Unicode code point to a glyph index. So the algorithms for that, they're probably a little bit different for each of the cmap formats. So it's not just parsing it, but it's using that data, which is going to be more work to support. So for now, I'm only doing cmap format 4. So it looks like the first thing is going to be a format, and that better be 4. So let's try to jump to that offset and then read the format. It's a uint16. It's a uint16, but we have to jump to the sub offset before we do that. And like I talked about at the end of the last stream, I'm pretty sure this offset is relative to the offset of the tmap table itself. So if I search for something where I've added an offset, that's too far back. Yeah, so it's going to be something like this. Maybe I can copy that. Yeah, I think that's what I'll have to copy. This is no longer to do because we're doing it right now. Probably do this all as one line of code. Maybe I don't need a separate offset variable. So it's going to be, do I already have this? I think I already have this as a variable. Is that inside my struct? I believe it is inside my struct. We'll find out in a minute when I try to compile. Plus the sub offset. So I think that's where we want to jump with the fseek subroutine. And then we read a uint16, that's going to be the cmap format. And I hope that that is for cali. Here's the namesake for the project. Come on, Cali. Okay. Want to say hi to Twitch? Want to jump up here? Make up your mind. There you go. Good girl, Cali. My cat, Cali. This is my cat, Cali. This font library project is named after her. It's also named after the concept of calligraphy, so I hope that makes a little bit of sense. Right, so I think we're reading this format. Let's print that and see if it's 4. That didn't work. Yeah, I have to declare it. I have to declare cmap format inside of my TTF struct. I just make everything 8-byte integers because I'm lazy. Hey, that's exactly what we expected. Okay, so that's good. Now, what do we read next? I wonder if I can just copy and paste this so that I don't have to continually switch windows. This is a lot. This is a lot of stuff. Put in a separator there for when we're done parsing the cmap data. Okay. Okay, format is done. Length. You could even do like a really fancy regex to just automatically replace this with like the line of code that you need to use one of my Fortran functions to read that certain type. Actually, they're all uint16s. So some of these are arrays. So when we get to end code, that's an array, and we're going to have to do something a little bit different there. But until then, we have format, length, language, seg count times 2 for whatever reason, search range, entry selector, range shift, and then end code is an array. End code. Do I want to make this a substruct of my cmap struct? Because I'm already like prefixing everything with cmap format. Length. I think we have something else called entry selector. Yeah, we already have an entry selector for like TTF, the TTF struct as a whole. So if I have something else within the cmap named entry selector, I should probably make a struct, a cmap struct, as like a separate namespace so that I don't have to be super careful about all of this naming. So maybe I'll come back to that in a minute. No, I think I want to do that now. So we're going to have a struct, and instead of manually emulating namespaces, we're going to replace all these underscores with the percent sign. In Fortran, the percent sign works like the dot in C, so this is how you access the child of a struct. FMT is a keyword. Okay, I guess that's why I use FRMT. Yeah, we had this problem in the last stream where I found out that when I had this variable named repeat, that was overriding the intrinsic Fortran function repeat. So actually I think what I want to do is I want to suffix that with an underscore. Okay, those are the only two places. Now, instead of and this will be good because there are actually 3 different cmap tables. There are 3 different cmap tables within this font file. For a general font file, I don't know how many cmap subtables there could be. So if we have a struct for the cmap, that will make it easier than if we have to do like parallel arrays for everything that could possibly be inside of a cmap. So it's a good thing that we're making a struct. Let's make a new type. Cmap type. Now the TTF file is going to contain a cmap. The reason I suffix my types with _t is so that Fortran is not case sensitive. So in any other language, you would have your class named cmap with a capital C, and then your instance of that class would be cmap with a lowercase c. Fortran isn't case sensitive, so I indicate my types or my classes with an _t for type, and then my instance of that type is just that without the _t. You'll notice that my glyphs are allocatable because obviously there are multiple glyphs in a font. I might make this allocatable in the future, so I have an array of cmaps, but I'm hoping that I can just parse the first cmap and ignore the rest, because the documentation is kind of vague about like which cmap one do you actually use when there are multiple cmaps. So I hope I can just parse the first and ignore the rest. And now the format is going to be inside the cmap struct. Let's do format _ so that I don't clash with the Fortran keyword FMT, whatever that means. I honestly don't even know what that is. Let's find out. So literally for a format specifier, they have the word FM. FMT isn't even on this page. Why is that a search result? Okay, Intel. Intel makes a very good Fortran compiler. So yeah, apparently that's where that keyword is used. It sounds like it's not a function, so maybe some of these keywords are safe to override, but repeat definitely wasn't, so I'd like to be safe. I think there might be other places where I make that mistake. Oh, sum. I remember I had sum, not checksum. Let me search for the whole word sum. Yeah, so if I clear the search, you can see that this syntax highlighting is different than everything else. So sum is a keyword. That's definitely a function. Like when you sum the entries in an array, that's what that's used for. So I want to replace that with sum _. Come on, man. Okay. There we go. I'm trying to use the dot command more in Fortran. Could have done just like a global search and replace, but I want to review all of these anyway. Okay. So that might be it for the ones that I'm aware of. I'll have to like review this entire file and search for things that are syntax highlighted differently. But yeah, I definitely want to replace those ones. Okay, so now the cmap format. Actually, probably want to copy this up top too so that I can declare everything. So we have format, length, about just len. Yeah, len is a Fortran keyword. Do I have any of those that I think I'm just using it as the keyword. Language code. Language code is a uint16. That's kind of weird. When you want like characters, like EN for English, DE for German. Whatever, TTF. So I just tab completed that because this is the whole reason that I made the struct. I already have something named entry selector in the TTF struct. So now if I nest that within a cmap struct, then I don't have to worry about them having the same name. I think I have range shift too. Yep. And then end code is going to be an array. So I want to parse up to and including the range shift, and then think about how I want to handle the end code, because I have to do some math to get the seg count from the seg count times 2, and then allocate the end code and a few other arrays, like all of those. So let's jump back here. I nested this within a struct, so I don't even want to read the other stuff yet. And then I want to see if I can still print the format, and that should still be 4. And then I replaced like sum and a bunch of other unrelated changes, so I want to see if that still compiles. Hey, it does, and it's still 4. What do you know? Everything's Gucci. And I probably want to put all of this stuff within the struct. Well, not the version, because there's one version and there's one number of tables, and then this stuff is nested within the cmap. And then now I can just name this offset. Don't need to give it a weird name anymore. Platform SID, and offset. So that should still compile. Now my alignment is all screwed up. Sure, I broke something there. Yep. How? I want to delete these from the TTF struct because now I'm not using those. And then instead of count, I want to name things consistently. Nseg. Count is too long. Nseg is the number of segments. Figure it out. cmap sub offset no longer exists. It's within the struct like that. There we go. That's looking good. I want to commit there because I did a bunch of unrelated stuff, and the code is not currently broken. If this untracked unicode file, maybe we'll get to that today. If I finish the cmap table and I can get ASCII working, then I might start to do unicode. But for now, that's untracked. So we didn't do a whole lot of parsing yet. The only new thing that we parsed is the format. Mostly we just declared a bunch of things and then renamed a bunch of unrelated things. So it's not a perfect commit message, but it's hard to break up work into chunks and say like this commit did this thing. I don't always work perfectly. I have things mixed into several commits. Several things mixed into one commit and then single features spread across several commits. So it's hard to discretize your work. And you can never make a perfect commit message, so I hope this one's good enough. Okay, so we have the format, then okay, yeah, we add a table length too. So that's why it's good to nest things into structs. Now you can have length as a member of multiple structs and the names don't clash. So because I've like changed the casing and done other minor renaming, I now want to copy and paste this down here. Okay, so we read the format. We can just do all of these at once. So length, language, nsig times 2, search range, entry selector, and range shift. And then the next one, end code is going to be an array. And that means we'll have to read it in a loop. Because there's more than one encode, you have the encode of each segment. But then before I do that, I want to print this stuff. So format, length, language, nsig, search range, entry selector, range shift. This is how I debug. I just use printf debugging because that works in every language and it works on every platform, and you don't need to learn like a specific IDE or how to set breakpoints. Like this works everywhere, so I don't have to relearn that for every language that I use. Cool. Length language nsig times 2 for whatever reason. If anything, you think it would be like divided by 2 if they want to compress things into a smaller number of bytes. I don't know why it's times 2. I guess that means it always has to be an even number. I haven't really thought out why they designed it like this, so that you have to do math to get the actual number of segments. So let's see what this is. That's not what I wanted to run. I wanted to run run.sh. Well, those are numbers. I have no idea if they're right, and I think font drop doesn't really show me any of these. Is this Computer Modern? Okay, so I'm looking at Computer Modern. This website allows you to drag and drop font files. So like I can look at Calibri instead. I'm not going to because it takes forever. Right now I'm looking at Computer Modern. I'm not going to redrop it because Chrome is a little bit slow for me. This isn't the fastest computer in the world. But this shows you what's inside a font file. So I'm using this to verify. Oh, I can verify some of these. Length is 536. And that's exactly what I'm reading. Anything else? Seg count is 65, but times 2, that would be 130. 130. What do you know? And then the rest, I'm just going to have to hope that they're correct. And I won't really know if it's right or not until I get to the glyph index map. And the glyph index map is not really explicitly stored in here. They just give you like an array of the end of each segment, and then from the segment ends and like the delta offsets or whatever these things are named, you have to construct the glyph index map yourself, or do it on the fly. It's going to be more memory efficient and more time efficient too, I think, if I just do this on the fly. With the arrays that they give me instead of constructing a whole dictionary or an array like this. I think this has to be a dictionary if you wanted to construct it yourself, because like this is mapping strings 0 to 0, and there are going to be holes in this, so it's not like you have 0 to something and then 1. Like the next thing is 13, so there's no 1 through 12 in here. That means this can't be an array. If your language supports dictionaries, then you could just use a dictionary for this. That's a little bit slow, though. It's faster if you can do array operations with like these parallel arrays. They give you seg count and start code, or end code and start code, and the delta and the offsets. So that should be faster. And that's what I'm going to do because Fortran doesn't have dictionaries anyway. If you want to see a dictionary, my interpreter project used a dictionary, because when you declare variables in a programming language, it's like all of your variables go into a dictionary, at least at parse time. If you made a compiled language, or like me where it's interpreted at the evaluation time, you can then convert that to an array, which is faster than a dictionary. But for parsing, as you're reading variables, you need to store those in a dictionary so you can like look things up sort of alphabetically to see if like a variable has already been declared or not. So I think that's in core here. And there are different data structures that you can use to implement dictionaries, but I used a ternary tree There are other things that you can use, like a tree, but spelled funny, like TRIE. Where's the Wikipedia page? Yeah. Yeah, it's a digital tree or prefix tree where you store, like, as you walk down the tree, you add a letter. So like T is first T, then E, then A. So that's a prefix array. And a ternary tree is kind of the same idea, except you can only have like 3 branches at each part of the tree. Not really sure what the difference is between a tri. Maybe this is pronounced try, not tree. I forget. It's spelled funny and might be pronounced funny. But yeah, if you want a dictionary in Fortran, you have to implement it yourself. So there's this ternary tree type that I did. I have one for functions and I have one for variables too. And then, yeah, there are functions for searching within a dictionary, and then there's a separate function for inserting a new item into a dictionary. There's tree search, or ternary search, and then there should be ternary insert slightly further down. Yeah, so here's ternary insert. Where's the actual thing? I have like wrappers of wrappers of wrappers. Yeah, so this is the ternary insertion where you like compare things alphabetically, and if it's after alphabetically, you do one thing. If it's before alphabetically, you go into a different branch of the tree. But that's all a tangent. So let's get back to the font. Yeah, I'm not going to use a dictionary for this because you don't really need it. They give you arrays because this works well with arrays. If you wanted to parse like all 14 variations of the cmap format, maybe it would be easier to program if you parse all of those differently, but then collapse them all into a dictionary so that when you're like evaluating that data structure, you don't need to have like 14 different algorithms for each of the 14 different cmap formats. You just have a dictionary in every case. So that could be a good argument to use a dictionary, but I might only want to support cmap format 4 and maybe like cmap format 12. Those seem to be the most common ones. And for those, I'm just going to use arrays. I'm not going to do a dictionary. Okay, so we have nseg times 2. Now we can divide this by 2 to get the number of segments, and then we can allocate that array, which is the next thing that we need to read. Do I even want to store it like this? Why is it times 2? Why do they store it like this? Okay, so I think you can use a binary search to look up glyphs or look up code points in this data structure very efficiently. So maybe like times 2 helps you with the binary search, and that's why they have like log base 2 of certain things. So like the way that things are compressed into the TTF format is tied to like the algorithms that are used to work with these data structures. So maybe that's why it's times 2, but they don't really say why it's times 2 instead of just having the segment count directly. Because like now it's a bigger number. Like it's actually 65, but then the number that's stored is 130. So like if you're worried about overflowing a UN16, why would you do this? If anything, it would be divided by 2, not multiplied by 2, because this is more likely to overflow now. There really shouldn't be that many segments, though. If you do have like a bunch of different segments, there's probably a different cmap format, which is more efficient. But I think that's fine. I'll leave it as ×2, and I'll just divide by 2 every time I have to use it. So I want the end codes. Did I already declare end code? No. Oh, I want all of these to be integer 8, just to be safe, and so that I don't have to worry about which things take up how many bytes. I'm not trying to be efficient here in this project. I just want something that works. And now I don't have to worry about like whether each member is uint16 or uint32 or int32 or int64. They're all just int64. Next is an array and character code. How is this uint16? Oh, okay, yeah, because it's a 2-byte. So format 4 only really works if you have 2-byte code points. I'm not sure if I'm using the right terminology, but like Unicode characters could take up to 4 bytes for a code point, but this format only works with 2 bytes, so that's why it's safe to have encodes as uint16. And that's why you need a different format, like format 12, if you want to support emoji or something that's outside of the basic multilingual plane. Since I have a struct for the cmap, I will eventually probably want a function to read this whole part of the cmap. Not the version and the number of tables, because that's not per cmap subtable, there's just one of those. But I probably want this to be in a function, and then I can like delete this leading TTF prefix from every time that I refer to the cmap. But for now, it's inside my read TTF function. This is read TTF. So this is how it is for now. And that means I have to type TTF very frequently, which is a little bit annoying. And seg ×2 divided by 2 to get the actual number of segments. And then we're going to read this inside a loop. Divided by 2 again. I don't know. Maybe it's better if I just divide by 2 right here, and then I don't have to do it down here every time. But for some reason, the TTF format decided to give it to me as multiplied by 2. So I guess I'll just leave it like that for now. And this is that one. And then I should be able to print the encodes. This is going to mess up my formatting anyway, so because it's going to be a whole array. Let's see what's in there. We should get like some ASCII range things. Well, there are going to be special characters at the beginning. Like I remember exclamation mark is one of the first few characters. But then we should get like Latin letter code point ranges. And then there are also Greek and Cyrillic things in here. So I don't know what those code point ranges are. If this even compiles. Hey. Okay. So does that make sense? So we have a segment ending at 0. That's like the unknown glyph. every font has to have an unknown glyph. Went to the wrong window. I get my browsers mixed up. So every font has to have this unknown glyph, which looks like a box with an X in it, usually, something like this. So this is the unknown glyph, and that way, if you try to typeset something in a font which doesn't have a glyph for the character that you're trying to typeset, they show it as this. So you've probably seen this on your phone at some point, like if somebody uses a new emoji and your phone operating system doesn't support that emoji yet, you'll see this, which is the unknown glyph. So every font has to have this at glyph 0, or yeah, glyph index 0. And then there are a few more weird things, and then we have exclamation mark. This is index 4, index 5. So this is a contiguous range. Index 6, yeah, so we have a contiguous range, and you're going to have one encode segment for each contiguous range. That's what a segment is. So apparently we have a contiguous range up to 13, and then we have a gap. So this is 13, and then we should have a gap. No, that's 14. I'm looking at the indices. But the Unicode D, hex D is decimal 13. So this is 13. So apparently we have a gap after that. I don't know if these are really in order. So then from 13 to 32, 20 in hex. Remember, this is hex, even though they don't really tell you that it's hex. This is really 32 in decimal. So between, god damn it, between 13 and 32, we have a gap. So that's the end of a segment. And then apparently there's a contiguous range that goes up until 126. Let me check an ASCII table. $126. Okay, so that's a tilde, and then 127, which is like the max ASCII character, that's delete. So it makes sense that we don't have a glyph for delete, because that's more of like a control character than a regular character. So it makes sense that we have an end segment at 126. And then apparently there's another contiguous range that ends at 163. That has to be some sort of like extended Latin thing, because ASCII, standard ASCII doesn't go above 127. And then, yeah, I don't know about the rest of these ranges. They're probably for Greek or Cyrillic or something else. Oh, and the last segment, I think, has to end at this number. This is like the maximum 2-byte integer, I believe. Is that, do they call it FFFF? Yeah. This is still within format 4. To ensure that the search will terminate, the final encode must be 0xFFFF, and that's 65,000, whatever, which we can verify with Python to quickly convert hex to decimal. So in case you didn't know, 0x, that was too many Fs, FFFF, that's 4 Fs. That is 65,000, so the final segment ends at 65,535. And that is good. So I think we're reading those encodes correctly. What's next? After encodes is reserved pad. It's not even used. There's just random stuff in this file format. Might as well save it. Why not? I have to declare these things too. I'm just going to call it pad. I'm not going to call it reserved. Oh no, pad is intrinsic. So I have to call it reserved pad. Reserved pad start code. That's going to be an array. Yeah, basically everything else is going to be an array. So start code ID delta, and a lot of these are the same size. They're all related to seg count times 2, but divided by 2. So just seg count. ID range offset. And then the final array, the glyph index array, this is not the same size as the other ones. I'm not really sure how to get the size of this one. I guess you have to look at how many glyphs there are, and then basically this array, if I understand it correctly, this is everything that's not covered by the contiguous segments. So if you have other like random glyphs that are just one glyph at a time without any glyph before or after it defined in that certain font, then you put them in the glyph index array, which is an even more sparse data structure, not like the contiguous segments. And that covers all the glyphs that aren't covered by the segment arrays. So I guess the size of this would be like the total number of glyphs, and then you have to subtract whatever's covered by the segments. But you have to do math to figure out how many glyphs the segments cover, because it depends on like the start code minus the end code, and then you have to sum all of those up, and that's going to be the number of glyphs covered by the segments. Yeah, so I'm not 100% sure what the size of this array is going to be, but it's going to be some kind of allocatable array. I don't do camel case in Fortran, because it's not case sensitive anyway. All right, I think that should do it. And then I'll delete this soon when I'm ready. To do loops in series. I can't read these all in the same loop because you have like the whole end code array and then a pad, and then the whole start code array. So I have to do separate loops for each one of these. I could make a function that reads in a loop. I have 1, 2, 3, no, I have 4. 1, 2, 3, 4 of these parallel arrays. So I think I want to do it without a function first, and then maybe I'll go back and refactor it. Yeah. I can allocate all of them up front. So let's comment that out quickly. So we have end code, we're going to have the start code, ID delta, ID range, and then the glyph index array, which is going to be a different size. And I might not even read this at first. Hey, Alvy, thanks for tuning in. Welcome to the stream. I'm parsing TTF files. If you don't know what a TTF file is, it's a font format. Apple has a lot of documentation on this because I think Apple created the TTF format. So this defines a font, and then we can typeset text. Like I can do Latin text, I can do Greek text, or whatever's in the font. But I'm sort of hard coding glyph indices. Like I know glyph P is at a certain index. Yeah, I know P is at glyph index 83. And then O, alphabetically, it's right before P. Actually, 83 is lowercase p, 82 is lowercase o, so these are alphabetically next to each other. So they have indices that are right next to each other. But this is bad. I don't want to hard code indices. I want to give my function a string and say typeset this string. And to do that, I need to parse this thing called the cmap table from the TTF file. And that tells you which glyph is at which index for that font. So yeah, that's what I'm working on. I hope that makes sense. Where was I? Yeah, I allocated everything. No, I didn't. So I allocated end code, and then next is start code, ID delta, ID range, and glyph index array. I want to get all of this aligned. That looks better. Okay, so allocate, and then I have to read them. So end code, start code, ID delta, ID range, glyph index array. I don't know what the size of the glyph index array is, so I might not even read that for now. Start code, ID delta, ID range. I think that should be it. Let's print these to see if they make sense. So again, start delta range. Not that. Something's a bunch of zeros. Some of those are very big numbers. Are these all uint16s? I think the start codes make sense. Do they? 32. Yeah. Okay, so I was concerned that 13 is both an end code and a start code. But then the one after that makes more sense. So we have 32 as a start code, but the corresponding end code is 126. So from 32 to 126, we have a contiguous range of glyph code points. So I guess those make sense. Then delta. Are these all uint16s? Yeah, they're all uint16s. Did I read the pad? Maybe I forgot to read the pad. I think I forgot to read the pad. Yep. So I think the pad was after the end codes. Pad. Yeah, pad is after the end codes. I don't know why the hell they have this in the format if it's just always supposed to be 0. And I forgot to read that, so that threw off, all of these are going to be off by 1. Yeah, so they should have the right values. They're all still going to be 2-byte aligned. If this was like 1 byte though, that would have made all of these values garbage though, because then I have like 1 byte from one value and another byte from the next value. So they're off by 1, but the value should be basically correct. Reserved pad is after the end code. So that thing should be 0. All right, good. The reserved pad is 0. And then start codes are 0 and then 13. I think we had like an extra 0 before. So if I scroll further up, the start codes were 0, then another 0, and then 13. So this was shifted off by 1 because I wasn't reading the reserved pad. But it's the same values, they're just shifted in the array, basically. So I think that's correct now. Now I have to figure out how to look up glyphs using these arrays. So we have more stuff that's not even used, at least not on Apple platforms. Sorry, this text is probably not readable to you viewers. So I'm hoping that these are zeros. ID range offset, was that the one that was like all zeros? Good. I think they're all zeros because that simplifies the algorithm that I have to use these parallel arrays to map a code point to a glyph index. So if this is 0, I just do like, first of all, I find which segment it's in. You could do a binary search to do that efficiently, but I only have like 65 segments. That's not huge. I can just scan the whole array to find the segment. So you find the segment, and that gives you a start code, and then you add like the delta or subtract the delta to the start code to go from a code point to a glyph index. That's if the range offset is 0. So these are all zeros. If it's not 0 for a segment, then you have some other algorithm that you have to follow. And this is a little bit complicated because we have to get like the address of an array element. And there's not a great way to do that in Fortran. So I'm not even sure how I would do this. But for this one, at least, I don't have to do that because the segments the ID range offset is all zeros, so I can use, like, they don't even give you a formula for it, they just describe it in text. Well, they give you an example. So like in this example, you have a segment from 10 to 20, and a segment from 30 to 90, and a segment from 100 to 153. And then you always have missing glyphs, so those always map to glyph index 0. So for this, you have like start code 10, 30, 100, from there 10, 30, 100, and then the end codes. This is a small example, which makes sense, and it's easy to follow. And then the ID delta, so that tells you, basically you subtract that from the start code, and that gives you the glyph index. So ID delta, ID deltas, wait, they're negative. They're negative. So why are you saying that it's unsigned? ID delta is unsigned. That makes sense why they're so huge now. But you're saying that they're negative. What the fuck, Apple? ID delta. So basically, like, it's okay. All ID delta arithmetic is mod FFFF. Oh, so here they give it to you in decimal, but like everywhere else, they say it in hex. This documentation is a mess. Somebody needs to overhaul this documentation. So these are the same numbers. 65,000 is the same as 0x FFFF, but there's no consistency in this documentation. Okay, so that's why my ID deltas, they're all like, most of them are just slightly below 65,000, whatever that number is, 536. Yeah, they're all slightly below that, so that means they're reasonable sized negative numbers. And that makes sense. Yeah. Hey Connie, welcome to the stream. Thanks for tuning in again. Got to refill my coffee quickly. I have it right here. I don't have to go into another room or anything. Okay, so I need to go from these positive numbers to negative numbers. Do I just always make them negative? Like, it's really not modulo 65,000, because if it was, you would end up with positive numbers after you take the mod. But I want to go from these deltas to some negative numbers. Oh yeah, don't worry about being late. These streams are archived on my YouTube channel, so like if you really want to see the beginning of the stream, you can always watch it on YouTube later after I upload it. I usually lag for a few days, so like I stream on Saturday and Sunday, but I want to space those out throughout the week. So like check within like a week. This should be on YouTube if you really want to see the beginning. But I don't care whether you watch it or not. So I think I always want to subtract 65,000 from these things. Because I want to get a delta that's like -9, -18, not 65,525. Just double checking this documentation. Yeah, this is the only place that they say this. So I'm just going to put that as a comment. And that did not paste where I wanted it to. Hopefully the compiler lets me do this. I might have to cast that to an integer, because I might get a compiler warning. Let's see if there were any warnings. Yeah. Then my deltas. Why is the first one huge? What was this before I subtracted it? Oh, it was 0. Yeah, so I do need some kind of modulo. Or that's still probably going to be a compiler warning, because apparently this defaults to like a 16-byte integer, at least with G4tran. So I might want to cast that to integer 8. Okay, now that one is 0. Oh, and these... Oh, no, I want it the other way around. So I want this... I want that at the end. Okay, now they're all negative numbers, or 0. And then, are there any compiler warnings? No, no warnings. All right. This might be one of those cases where it works for me locally, but then like the Ubuntu worker on the GitHub instance might warn me about this integer casting. But locally, at least, it's okay. So I think that's all of the cmap data that I need. Eventually, I might need to read this glyph index array, but I don't really understand how that works yet, because I'm not sure what size that array is supposed to be. The documentation is a little bit confusing. So I should be able to use this to map from code points to glyph indices. How do I want to do that? I probably want a function that does that. And then my draw glyph function. Well, I can still take a glyph here, but then in main, when I call glyph, when I call draw glyph, I want to get this index by looking it up from the cmap data that I just parsed. Did I expect good docs from Apple, the most pro-dev and pro-consumer company known to men? I mean, the documentation has been good so far. This is like the first day that I've really had a gripe with their documentation. Uh, like it's fairly comprehensive. Like look how many tables there are. Like each one of these is potentially just as complex as the cmap table that I'm looking at. So like it's a lot of documentation. I guess it's quantity over quality. I don't know. Up until now, I was looking at this guy's blog. So Steve Hanoff has a blog on how to parse TTF files, but he doesn't really cover cmap in the blog. He says that like he does it on his GitHub, but I haven't looked at his GitHub yet. For the cmap, I'm experimenting and I'm trying to do it from the Apple documentation itself instead of looking at somebody else's code. And yeah, it kind of worked out until I had this gripe about the inconsistency of FFFF in hex versus decimal. But yeah, I don't know. Maybe I just need to level my expectations. So I think I want a function that takes either a code point or just a character and then gives me the glyph index. I think I want to give it a character. So like, for example, just the letter P. And then it should give me 83 for lowercase p. Yeah, but a lot of docs not mean a lot. Yeah, it's quantity over quality. So I think I just want to test it in main. So we can do it anywhere. We might as well do it here. What do I want to name this function? Maybe get index. Do I have a function named that already? No. That's good. So I don't remember exactly what it was, but a few years ago I was working with some API in the docs for it. I just wanted to jump out of the window, even though I was living on the first floor. Yeah, technical documentation is not always easy to consume. So I want to have some function which gives me the index of a glyph, and it's also going to take the TTF struct. I think that's all that I need to pass to it. Because this could vary from font to font. One font might have Latin characters, so it only defines glyph indices for those, and another font might have like Greek and Cyrillic characters, so it has indices for those. So this will depend on the font. And now I want to define that function. About CH. Can't be index because that's a keyword. Let's just do I. Don't have to spell out index. So at first I want to do ASCII, and that would just be a single character, CH. But I might want to extend this to Unicode, like more than just standard ASCII at some point. And the way that I'm planning to handle Unicode is to have an array of characters or a string. So in general, a Unicode character could be 1 byte or 2 bytes or 3 bytes or 4 bytes. So this isn't necessarily just a single 1 byte character. So it could be up to 4. So I will make it like that for now. The docs were already a few years outdated, and the API had only a handful of endpoints that still existed, but even those worked completely different. Yeah, documentation tends to go stale if somebody doesn't maintain it. That's annoying when that happens. So we have the character, and we have the TTF struct too. Let me just steal this from my next function. So we have these parallel arrays. We have end code, start code, and delta. I think those are the only ones I need. And if ID range offset is not 0, then I have to do something different, which I'm not going to worry about yet. So the first thing I need to do is find the encode. Find the first encode, which is greater than or equal to my current character. I think that's the way that this is supposed to work. So I'm in format 4 here, and then end code. So this paragraph basically describes how you have to use these arrays. Search for the first encode that is greater than or equal to the character code to be mapped. We could just copy that and make a comment. Me, for example, I of course always write comprehensive docs for everything I write, and definitely don't ever do stuff that not only has no docs but not even useful comments. Yeah, I can't blame Apple, since I'm not really any better. Let he who is without sin cast the first stone. So we're going to have an integer for the segment. Do I want that to be 0? I think I want to initialize it as 1. And then we're going to scan until we find that right segment. First encode that is greater than or equal. So the opposite of greater than or equal is less than. So while TTF cmap end code is less than the character code. Now, the character code is tricky. If we assume it's ASCII, that simplifies things. In general, the code could be more than 1 byte. So I think I want to have a different type for this. I think I'll call it code point. I can't understand how to write useful comments. I've opened a project a few days ago, which I've worked on just 3 months ago. I didn't remember a single thing and started to rewrite everything because I just didn't understand what I was trying to do. Yeah, and it doesn't help that there are different philosophies with comments. Some people say, like, write lots of comments. Other people say like, actually comments are bad. You should just name variables and functions in a way that you don't need comments. So you shouldn't write comments. Yeah, so there are different philosophies, and like you just don't know what to do. Should I use comments? Should I not? I think the right answer is somewhere in the middle. You should try to use variables and functions that are self-documenting, but you should also use comments. Uh, it can be a problem. So you can have bugs in comments. Like you can have a comment that says one thing, but then your code actually does something else. Or maybe like the comment used to be correct, but then you changed something in the code or you fixed a bug in the code, but you didn't update the comment. So that's how you can introduce bugs into your comments. So yeah, it's hard. It's not easy. Okay, so this should scan for the segment. Well, my name var is very great. Int ijk equals 0. Yeah, I have a lot of that too. Even the function that I'm in, result I. I mean, like the function is named index, so I think this is obvious. Oh, okay, and functions f1, f2. I, I, I hope I'm a little bit better than that. I have get index. So I need the code point. For ASCII, it's fairly simple. For Unicode, like I have this untracked file. I have this untracked file that I'm working on that will help us decode or encode or just in general transcode Unicode code points to and from UTF-8 or UTF-32. UTF-32 is just the code point, if I understand that correctly. But for ASCII, it's simpler. You don't really need to do any transcoding. It's just the ASCII character index. But that's going to be a 4-byte integer. Or is it 8-byte? I'm not really sure because it might overflow. I think we can do a 4-byte integer. So for ASCII, I think that's just I ACAR of the character. So I think I've used this. No, I haven't used it in here. Well, most of the time functions are named better, but I'm getting into competitive programming and there's literally just IJ, A, B, C, F1, F2, F3 because I can't waste time and energy thinking 5 minutes on how to name a single function or var. Yeah, you're right about that. Like when I'm streaming here, you'll see me just pause for a minute and think like, what should I name this thing? And that does take a lot of time and mental effort. So I can see if you're in like a timed competition, then you don't want to waste time on it. So in that case, that's also like, I don't know if I should say throwaway code, but it's like single use code. Like you're going to write it once for that competition, and then you're probably not going to go back to it or reuse it for anything. So you don't need to use good variable names or function names in that case. So this is for ASCII only. And then we'll have to modify this for Unicode. But I think we might be able to test that now. Will this compile? Let's see. Okay, I messed something up real bad. I probably just have like the function name isn't the same at the end tag. I did not declare I. cascading errors are really annoying. Here's the first error. Unclassifiable state. 519. Oh, duh. Yeah, I knew it was something like that, because if you don't end the function, then like this thing and everything that comes after that in the code, that's going to cascade as like yet another unparsable error for the compiler. Come on, man. Ah. There we go. Okay. Last year I was competing in a hackathon and I wasted half an hour discussing what to name a function. Thankfully it was a 72-hour hackathon. Yeah. Well, you live, you learn. I've never done a hackathon or any type of competitive programming. Uh, I did Advent of Code last year, or at least I attempted it. I didn't really finish it, so maybe that counts as competitive programming. But yeah, aside from that, I've never done any competitions. Okay, so the segment is 3. I think that makes sense, actually, because we have... First of all, I should print the code point, too. The segment ends, we have one that ends at 0 and one that ends at 13, and then one that ends at 126. So the one that ends at 126, that contains like almost all of the ASCII characters that aren't control codes, like the first 13 or so, are mostly control codes. So for a lowercase p, that should be segment 3. So I think that makes sense. I think I want to not recursively print. Okay, so the problem is that I was calling this function in the middle of a print statement, so that looked a little bit funky. Like it printed out like this. I want these to be on separate lines, so that should be better now. Yeah, there we go. Now it says segment 3, and then I'm just returning 0 because I haven't actually finished this function yet. So we have the segment, and then I think there's special logic if the start code is the same as the end code. Yeah, so if they're the same, then it's the unknown glyph. So if the start code is greater than the end code, then we have to do the missing glyph. And if you look at the last segment, so I don't think we have anything in this font. It's like that. But I need to put in logic for it anyway. So in this case, we return the missing glyph, which I think is actually I = 0. And then we can return early, but for the default case, we can actually look up a defined glyph. missing glyph, missing character glyph. So the next thing is that the ID range offset has to be 0. If it's not, then there's like special logic, which I'm not entirely sure how to implement in Fortran because we have to use pointers and memory addresses. It's going to be difficult. There should be a way to do it, but I'm not going to worry about it yet. But if this is 0, I'm just going to throw an error for now. So, if it's not 0, I think that's consistent with the way that I'm handling errors. Yeah, it's not great, but this will just abort execution if that happens. So it's like an assert. Okay, so I think it should be pretty simple. It should just be the start code minus the delta, and that should be the index. Start code for the segment which we've scanned for. I think it should be minus the delta. I think that's it. 60? That doesn't seem right. Isn't it like 83? Yeah, I'm expecting 83 for lowercase p, so that doesn't seem right. I've just watched your spicy chip video and the complete lack of reaction in comparison to other people I've seen eating it. Yeah, I'm a little bit of a chili head, so it was only like a 1-minute video. I think that was originally on TikTok. Or no, I guess I had a longer video on YouTube, if that's the one that you watched. So yeah, uh, I can handle the spicy taste. The worst part was like stomach pain that kicked in about like an hour after I ate the chip. So that was kind of bad. But yeah, the first 12 minutes, it wasn't too bad for me because I can handle spicy taste. Okay, so this index is wrong. What is the ASCII thing, first of all? Yeah, what is the code point? For lowercase p, the code point should just be the ASCII value. So it should be 112 in decimal. I think that's what I expect. So the code point is 112. That's saying index 60. That's not right. Oh. So this would be like the first character in the segment. but I have to add I think it's just the code point. Nope, that's not right either. So I think it's the code point minus the start of the segment. So it's 112. We know we're in segment 3. This example might be helpful. We should just subtract the delta. Oh, but the delta is negative, so I actually have to add the delta. Because like the delta, these deltas are already negative. So you don't subtract the negative number, you just add the delta. And that's pretty close. It's off by 1. This is probably because Fortran uses indexes that start from 1 in every other language, including like the TTF spec uses indices that start from 0. So this should be easy to correct. I mean, I like very spicy stuff, but as you've said in your vid, it just doesn't taste good. I haven't eaten this chip, but other spicy challenge stuff, and it was never as spicy as I hoped, but always just tasted awful. Yeah, like it was really bitter. I couldn't like come up with the word bitter in my vocabulary during that video, but yeah, it was like a bad bitter taste. And then like the heat kicked in afterwards. Yeah, it was spicy enough. Like there wasn't any disappointment there. But like if you're expecting a good flavor from the single Pocky chip, you're not gonna get it. Uh, so I'm expecting 83 for lowercase p. So I think I just need to subtract 1. Uh, so that makes sense. Yeah, next I should be able to look up characters pretty easily and then typeset a string instead of typesetting hard-coded glyph indices. I might be ready for a commit though, because we've done a lot of parsing and then we defined this get index function. Could use a binary search here to be more efficient because the encodes are guaranteed to be ascending by the TTF spec. I only have like 65 segments though, so it's not terrible to just linearly search. All right, yeah, thanks for tuning in, Connie. I really appreciate it. I don't entirely understand where this off by one error is coming from, but it seems like it's easy enough to correct for it. Doing code point plus delta. Maybe my ID delta is off by one. So maybe this should be not minus that, but maybe it should be like that, whatever that is in hex. So that essentially adds 1 to the ID delta. And then if I add 1 there, then I don't need to subtract 1 there. So I think that's the same thing. It should still be 83. Okay, so I think that makes sense. And then all of my deltas, these should be different by 1 than they were before. If I can scroll that far up. So we had 0, then -10. 0 doesn't change. 0 is always 0 because it's modulo. And then we had -10 and -28. Now we have like -11 and -29. So yeah, now this is -11 and -29. I think that's why I had that off by 1 error, but I think this is correct now. And then I don't need to correct for it here because it's built into the delta. So I think the deltas were off by 1 before, and then I shouldn't need to do any off by 1 subtraction here. So I think this is the way that it should be. But I'm going to leave this commented code there in case I want to come back to it later. I can delete those other 2 lines there because this is close. The other 2 were way off. So yeah, I think I can commit here. Let me do my tests. The tests are testing the ppm format, so this should be entirely unrelated to what I've just done. All right. And then this thing shouldn't really be any different. All right. I think that's the same. So let's quickly review and then commit that. So we did quite a lot. We parsed the entire cmap table, and then we added this get index function. I need to add an assertion that this is for format 4. So that should be right here. That shouldn't change anything. It should still run. But now if I try to parse some other font file that has a different cmap format, it should stop right there because I don't know how to support those other formats yet. It's enough work for just cmap format 4. I'm not going to support all 14 cmap formats. Maybe 12, but definitely not all 14. That's it. Now I want to really use this function and typeset a string. So back in my main program, instead of using these hard-coded indices, now that I have this getIndex function, I can typeset a whole string, at least for ASCII. We'll have to go back and add Unicode support later. But I think I want to comment out most of this stuff. Let's test a couple other indices. So let's try a capital P, because capital P is different from lowercase p. Capital P should be index 51, and then 82 and 74 are what we expect. 51, 82, 74. 51, 82, and 74. That looks good. So now we can use this function to automatically get indices. I'll just put it in main for now, I think, and then we'll refactor that as like a draw string function instead of draw glyph. Yeah, so let's have a string to be typeset. We'll call it str. Pogue. And then we can, for ASCII, we can just loop through each byte of the character. In general, for Unicode, the number of bytes in the Unicode string won't necessarily be the number of characters that we're going to be typesetting, because a Unicode code point could be anywhere from 1 to 4 bytes. They're not all the same size. And the reason that Unicode does that is so that ASCII is both compatible and can be compressed pretty well, so that you only need 1 byte per character for ASCII. But for something like Chinese, where there are thousands of logographs, then you can use more bytes because you need them. But yeah, ASCII is compatible with, Unicode is compatible with ASCII, it's backwards compatible, and Unicode can compress ASCII text because it only uses 1 byte per character for that. So we're going to loop through each character in the string. let me just confirm that I can loop through that correctly first of all. What is wrong with that? Oh, okay. So I already, again, I'm conflicting with a function that I've declared. Where's the function? So I want to rename this to str. And then where do I use this function? I think that should be okay now. Wow, how did that? Okay. It worked before because the function had the same name as the return value. Okay, now my test source needs to be updated too. Hopefully that's it. Okay, POG. We're looping through the characters of the string. Now we can get their indices and then typeset them. And we're going to have to do something nasty for kerning. So the glyph index what do I want to name it? I think I do want to name it iglyph. Isn't this, doesn't it have to be integer? Okay, it's just an integer, I guess. I don't know if those types match. I thought the function was integer 8. So get index, yeah, this actually returns integer 8. So you probably have some compiler warning buried up here. I guess not. Yeah, but it's better if these types match. So this should be integer 8. Not the default integer 4. So again, this is ASCII only. For ASCII strings, we can index them by bytes because every character is 1 byte. For Unicode, this is going to be different. We're going to have to like convert it to a vector of code points first and then loop through that instead of looping through the string directly. So this is ASCII only. So we get the index, and then we can typeset that index using the drawGlyph function. So we have the canvas that we're typesetting it into. We have the foreground color. We have the font, TTF struct. Then we have the glyph, which is just one index now. We don't have an array of indices. We need some sort of spacing. I can use I to put in a spacing. How do I want that to work? I want it to be like, it's going to depend on the resolution that I'm using in pixels per M units. M is the unit of a font. M is kind of like the bounding box of a single character, roughly. Some characters might be smaller than an M, but like the largest characters should be roughly an M. Some of them might overflow. You never really know with modern fonts. So I guess I want it to be like this. Then I probably want to add, yeah, maybe I want to add some margin. I don't know. The Y position is just going to be 1 times the line height, and then this is the resolution. So I think that should work. Let's see if that'll do anything. This is what I was printing before. I don't know if I've changed this file. Yeah, so I've basically wiped it out. After I run this, you should see pogue at the top, because I'm only typesetting 1 string. If it compiles, it doesn't compile. There's the warning that I was expecting. Oh, I forgot to pass TTF. I'll deal with those warnings later. I might just remove it from main. So we should see pogue. There it is. It's indented a little bit more because I started kerning at 1 M rather than 0 M's without any padding. But yeah, I think that's it. I don't know if I want to get Unicode sorted. This can definitely be a commit. So this is pretty cool. We're drawing an ASCII string without hard coding indices. We're looking up the glyph indices automatically from the cmap table in the TTF file. So we can typeset any ASCII string now. In fact, maybe I want to do like 2 different strings before I commit this. Big Chungus. And let's do Chungus at line 2. And this might overflow. Let me make my canvas 800 by 600 because I think Chungus is going to be a little bit bigger. It's a big Chungus. It's not your standard size Chungus that we're dealing with. Yeah, it looks pretty fucked up. Like the kerning is terrible. This I is a lot closer to the B than it is to the G. Yeah, that's close. Maybe 1,000, or I could decrease my resolution in pixels per M, but I'll just make the canvas bigger. There we go. That's a big Chungus. All right. Yeah, I think that can be a commit. That's it for that. Might want to try Unicode because like I have this untracked file that's basically ready to go. I'm gonna take this out. Don't need to test the index lookup for individual characters because I can just look at the image and see if it worked there. I can also get rid of most of this. There is one thing that I want to keep. I want to keep the cali string because I want to try Unicode. Yeah, so this isn't going to work because if we look up individual bytes, this is going to be garbage. It might even crash or throw an error. Did something. Yeah, so we get emoji bake. And that's because I'm only doing ASCII, so if you try to typeset something that's not ASCII, like Greek letters, that doesn't work. Graph works, but cali in Greek letters doesn't work. So let's see if we can support that. I have this UTF file, which is all set up. It even has a program. So what it does is it starts with a UTF-8 string. It transcodes that to code points, which are basically UTF-32, and then it transcodes the code points back to UTF-32, and it checks that that round trip successfully got back to what we started with. Because if you go from UTF-8 to 32 and back to 8, you should end up with the same thing that you started with. That was actually a separate program, so I was running it like this. And yeah, the input is cali. You get a vector of code points. Each of these could be 1 to 4 bytes. And then we go from the UTF-32 code points back to a UTF-8 string. And that is the same as what we started with. This is just Greek for cali. The word calligraphy comes from Greek. It means it's from cali, which means beautiful, and graphos, which means writing. So calligraphy is beautiful writing. And this is kappa, alpha, it's like the Greek A, lambda is like L. There are 2 L's, and then there's iota, which is like I. So this says cali. Yeah, so that's how that UTF-8 transcoder works. But this is a program. I don't want a program in here. I want it to be a subroutine that I can use in my library, or rather a series of subroutines that I can use in my library. So I want to comment out that main program and then add it to my build script. I don't need to look at this hex editor anymore. So my source will now also need to refer to the UTF-8 function. What is it actually? It's UTF-8.f90. I might want to rename it later to just UTF.f90. But for now, that's what this is. That should still compile. Right. Yeah, it's 8. Okay, that still compiles. And now in here, instead of indexing this string by bytes, this string is UTF-8. So I want to rename this variable first of all. so that shouldn't change anything. Should still have emoji bake and then graph. Yeah. This takes a second to reload, so it's not like instantaneous, but yeah, I think this isn't changing. And then I want to go from a UTF-8 string to a vector of UTF-32 code points. So the way that I did that is to cpvec. CP is code point, but a Unicode code point is really the same as UTF-32, so I might want to rename this. But the cpvec type is integer 4 because each code point could be up to 4 bytes, so I'm using a 4-byte integer to store that, and then an array of those to store a whole string of them. So let's get that. I don't want to call it cpvec, I want to call it a UTF-32 string. And that's an array. Character arrays in Fortran are a little bit weird, like we don't put this here, that's in the length there for some reason, so there's a little bit of an inconsistency there in Fortran. But these are both strings, even though it looks like they're different ranks. They're both like a rank 1 array. So yeah, my UTF-8 string, and then I want to convert that using, I want to convert it to a code point vector. And then I can loop through this array instead of the UTF-8 string. So UTF-32. Well, there's not really a good way to print that, so I'm not going to bother printing it. And then I think my get index function takes a character, not a code point. So I'm just going to focus on cali for now, and then we'll go back to graph later. So this is 32. We're working on this so I can get rid of the to-do note. But now I need to update this get index function to take a code point instead of a character. So this is a 4-byte integer. That's how I'm encoding the UTF-32 code point. And then don't really need anything. Eventually I can just replace this variable so I don't have like this temporary variable that it's not really needed. But I think I'll just leave it there for now. Yeah, and they're both integer 4, so that should be okay. And hopefully this just kind of works. Let's see. Right, this is size instead of len. Because you use size for arrays and you use len for strings in Fortran, again, that's a little bit inconsistent. And then you index strings differently in Fortran, so yet another inconsistency. This is just str. And then I need to use the Unicode module. Is that what it's named? UTF-8_M, so I might rename that. Well, that didn't work. 135. So we have that. So it's a character. I use 2cp_vec. 2cp_vec on a character array. Not sure what's wrong here. Because I tested this in here. It worked in this program. Might need to take a break soon. I was hoping this would go smoother than this. This worked. This worked in my program. Hey Dink, welcome to the stream. Thanks for tuning in. So it works here in the independent program. But when I try to link that into my library, it's not working for the same string. Like, we're not even getting to the font typesetting. We're just trying to transcode UTF-8 to UTF-32, and that's not working. But why? Is it one of these compiler flags? Gone through a few different iterations here. That did something. We're hoping for cali at the top. Graph at the bottom won't be there because I have to fix that up. Nope, there's absolutely nothing. Did I just comment it out? No, I tried to typeset it. Let's see what code points we're getting. I mean, at least it didn't crash. That didn't work. So I use UTF-8 module. Why does it give me zero information about where it's crashing? Like, I'm compiling with all the debug options. And now it didn't crash. Still nothing. We get an empty string. Now it crashes again. So this string is 5 characters long, but I think each of these is 2 bytes. So that would be a length of 10 bytes, and 14 isn't crazy far off from that. But it doesn't seem exactly right. There's something terribly wrong with the way that this is a module. Because it's not passing this string incorrectly, and it ends up with a length of 0. It really should be 10, because it's 5 characters, but each character is 2 bytes. So this is a length of 10 bytes, 2 times 5. So that makes sense, but then inside the to code point vector function, getting a length of 0. And that doesn't make sense. Okay, what if I take out the typesetting functionality from my program? So what if I take out that and take out that, and then have some custom types here. So I need to comment this out, and then just take out all the typesetting stuff. So comment that, and comment that. So will it work if I only do the Unicode transcoding? No, because I forgot to comment out new color. So it's going to be a lot of work to uncomment that when I go back to it. So it's still the wrong length. I mean, at least it's not 0. Or it is 0. It's different every time I run it. If I change the order of my source files in cmake, does that make a difference? It shouldn't. So it's like it's different every time I run it. Sometimes it's 14, sometimes it's 0, sometimes it crashes, sometimes it doesn't. So that's not good. What if I undo this piecemeal commenting? And what if I just paste in the whole other program? Oh God. I renamed some things, but not everything. So this is kind of back to where we were. Got a whole bunch of viewers now all of a sudden that like nothing is working. I wish you guys were watching like an hour ago when things were going smooth. I've been going for like 2.5 hours, so I think I have to take a break soon. So this crashes, but what if I take this program? What if I just run this program instead? Never actually seen Fortran code. Well, there's a first time for everything. I wonder if my source file is messed up somehow. So that program works when it's all within one source file. But when I try to link it to the rest of my library, it doesn't work. And I wonder if like the text file, the fortran.f90 file is encoded differently. Anyway, let's hex edit this to see what the first byte is. 0A21 is 21 just an exclamation mark? I think so. Unicode 21 is an exclamation mark. So like there's no special byte order mark at the beginning of this file. It's just a new line and a bang. And if I look at my main program, it's a new line and a bang. So again, there's no special byte order mark. What if I open them as binary? Same thing. 0A is new line, 21 is exclamation mark. Same thing. Yeah, so there's no special byte order mark in the beginning of this source file. So that's good. Is it my compiler flags then? I comment all of that. No. So we can check if it's my compiler flags. I run g-fortran manually. Let's call it UTF-2. And this is main.f90. Yeah, because it's more than one source file. So it must be my compiler flags, or cmake somehow. It has to be my compiler flags. So I can just comment all of these out. Must be my compiler flags. All right, let's try that. I don't even remember what I have enabled or disabled at this point. Is this trying to typeset anything? It is trying to typeset stuff. Hope these code points are right. All right, let's see what's in here. Let's go. These are Unicode characters, typeset from Fortran. And all of my viewers left. Come on, guys, I finally got it working. Oh, Dink is still here. Thanks, Dink. I really appreciate you sticking around. Yeah, so Fortran itself does not support Unicode. I have to do the transcoding myself. Fortran only really supports ASCII. In fact, if you try to interact with the operating system at all, like if you try to open a file that has Unicode characters in its name, this stuff really isn't going to help. But I have a language that only supports ASCII, and I'm typesetting Unicode characters in it. So I think that's pretty cool. That took a little bit longer than I thought. I thought I could just copy and paste my Unicode source file in here and then get it running, but it took me a long time to figure out that somehow one of the compiler flags, and I don't know which one of these is stopping it from working. So I'll have to go back and get that working later. Chad behavior, you said it, not me. Yeah, so that took longer than I thought it would. I'm probably gonna commit and then end the stream within a couple minutes. So let's see what I did. First of all, I have a new file. These are all binary files. This isn't really a binary file. Actually, we can look at it. I think it's like partially, okay, it is binary. It's like partially compiled Fortran stuff. That's what it makes for a module. Usually with cmake, it puts that in a subdirectory, but because I was running g-fortran directly, I have this untracked binary file here. I'll clean those up later. But yeah, I've modified several things. I have to figure out why these compiler flags are breaking my Unicode feature. So I've got to figure that out, but it's not going to happen on this stream. Let's review what I've done quickly. cmake, cmake. We're basically passing in the UTF-32 code point, so we don't need this temporary variable, but I'm leaving it in there for now. And before I end this, let's try some other string. Let's try a different Unicode string. I know this font has Russian characters. So let's go to Google Translate. I know I want to say Privyet, but I don't know how to type Privyet. So I'll just translate to Russian. Copy that. Let's see if this works. Paste that because I don't have a keyboard for these characters. Hello world. I can do Greek, I can do Russian. I can basically do anything at this point. I do have a lot of limitations of what kind of font files I'm able to parse at this point, but this is pretty good for now. I was planning on doing something similar for my OpenGL project, but TTF gave me a headache. Yeah, I've spent like a good 15 or 20 hours at this point on this project, just parsing TTF files and getting to this point, even with sort of fucked up kerning. So it's a decent amount of work. One of the things that inspired me to do this is that I was trying to make like an OpenGL program in Rust. I was like visualizing scientific data, and I wanted to add text for like a legend, and I could not get text to work at all with like the versions of the libraries that I was using. So I was like, why is text so hard? Why are fonts so hard? The only way to learn is to do it myself. So that's what inspired me to start this. But yeah, it's a headache. The reason that there's a lot of bad font software out there is because it's kind of complicated actually. It's not as easy as I thought it would be. I think I already reviewed all this, and then I did a different string. So I think that's it. I want to make sure I have, yeah, these are just binary files that are untracked, so that's fine. Add Unicode support. I think I might just generate signed distance fields and just do it on GPU, but it's a cringe solution. I had another viewer who was watching me like a week or two ago who was also working with SDFs and like multi-channel SDFs. I don't really know anything about that, so you'll have to chat with my viewers instead of asking me because I don't really know anything about fonts or typesetting. Everything that you see me do on these streams, I'm learning it as I'm doing it, so I'm really not any kind of expert. But yeah, all right, we committed, we pushed. This might break CI. There's probably something that I did that works locally that doesn't work. Yeah, this isn't working on the cloud. I don't even care to look at the error message right now. This is long enough of a stream. So thank you to all of the viewers who tuned in. I really appreciate it, and I will catch you next time.